All right, this is lesson 4.3. This is our third video, third of, you'll see 3 or 4. And we're going to go on now and graph the tangents and the cotangents. And in terms of emphasis, the most important thing we did in chapter 4 is graph sines and cosines. And so now we did, after sines and cosines, we did secants and cosecants, which followed from sines and cosines. And now we get to the tangent and cotangent graphs. And it's nice to take a look at them and see how they're graphed. But it's not really going to be the main focus. The main focus of the chapter was really sines and cosines. So this will give a little bit shorter treatment to, you can apply some of the things from sines and cosines to the tangent and cotangents, but not quite as important. Okay, so let's look at a tangent graph, and let's just first, there's a screen right there in front of you, but let's just look at it again. Let's just see what a tangent graph looks like. I'm going to clear these out of here. And so tangent, let's just hit tangent. We'll go zoom trig. And we get this funny looking graph here. It's a little different than one. I like this one actually better than the one that's in front of you. So we get this, cover up that other one. We get this tangent graph. Oops, come on over. This tangent graph that looks like this. I'll make it a little bit bigger maybe. It looks like this. And so things to see about a tangent graph is it starts at 0, kind of like a sine graph. It goes up to the right and down to the left. And then very interesting, it has a vertical asymptote right here at pi halves. We're going to talk about that in a minute. So it's a vertical asymptote. Then at pi, the tangent is 0. So at 0, and at pi at 0, goes down to the right, down to the left, up to the right. Then at 3 pi halves, another vertical asymptote. And it keeps repeating. So one thing kind of interesting about a tangent graph, and this is just y equals the tangent of x, this one has a different period. Notice, this graph repeats between negative pi halves and pi halves, or between pi halves and 3 pi halves. The period of this graph, the time it takes to repeat, is only pi, which is a little bit of a change. So just for our normal tangent graph, the period for a tangent graph is pi radians. Sine, cosine, secant, cosecant, all those were 2 pi. But a tangent repeats every pi. That's kind of interesting. Okay, so what did we notice here just looking at the graph? The tangent of 0 was 0. The tangent of pi was 0. The tangent of 2 pi was 0. So we noticed that. What else did we notice? We noticed there's vertical asymptotes at pi halves, 3 pi halves, etc. Okay, I think I want to skip a page and just go to the explanation of this part. Let's see. Yeah, let's skip cotangent. Let's just talk about, why does this make any sense that a tangent graph is that way? And let's remind ourselves from chapter 1, we had this important quotient identity. So what's the tangent of x? Tangent is the sine divided by the cosine. Okay, let's think through this a little bit. When would tangent equal 0? How could you get a fraction equal to 0? It's going to equal 0 when the top of your fraction equals 0. It equals 0 at the exact same places that the sine graph equals 0. And then you think through your sine graph, which hopefully you're very familiar with. What does a sine graph equal 0 at? 0, pi, 2 pi. All right, let's look back and see if that agrees with what we just said. Look at that. The tangent, like the sine, is 0 at 0, pi, and 2 pi. Why would that be? Because look, tangent is the sine divided by the cosine. All right, next thing for a fraction. When is a fraction undefined? So it's undefined when the bottom is 0. So when the denominator is 0. So undefined when the cosine equals 0. Where is your cosine graph equals 0? And again, you think through that. That's when x equals pi halves, 3 pi halves, etc. What does undefined mean? Undefined means you're going to have a vertical asymptote. And so again, look back at our facts here on our tangent. And those were our facts. Vertical asymptotes where the cosine is 0. At pi halves, 3 pi halves, etc. Okay? So we're not going to spend a lot of time on this. I would remember tangent is 0 at 0, pi, 2 pi. It goes up to the right, down to the left. All right, let's come take a look at cotangent graph. Look at this, guys. Down to the right, up to the left. So it's kind of switched of our tangent graph. And let's think about our cotangent. Cotangent is going to be cosine over sine. Where would our cotangent graph be 0? So cotangent x, where would that equal 0? The same place, the top of the fraction, the numerator equals 0. Where the cosine is 0. Where's the cosine 0? Pi halves, 3 pi halves. So everything gets switched around between a tangent and a cotangent. So the zeros now are at pi halves, or the cotangent of 3 pi halves, etc. 5 pi halves, 7 pi halves, plus or minus, that would work. So that's where the cotangent is 0. Where is the cotangent of x? Undefined, meaning where does the cotangent of x have vertical asymptotes? So vertical asymptotes, where the denominator, where the bottom of your fraction equals 0. Where does the sine equal 0? At this point, hopefully that's routine, at 0, pi, 2 pi. And sure enough, we have vertical asymptotes at 0, pi, 2 pi. So those are your facts, or look, it's listed down here as well. So those are the facts you want to remember about tangents and cotangents. And again, if you relate it back to cosines and sines, not real difficult to remember. All right, let's see what one of these graphs would look like here. So here is the tangent of 2x. All right, now we need to apply what we learned from sines and cosines. You know, what does this 2 do? Before we do that, let's just remind ourselves. Tangent of x. Where is it? 0. So we'll just call these our zeros. Where's the tangent 0? Same place where the sine is 0. So when x was 0, pi, 2 pi. What were our vertical asymptotes? So vertical asymptotes, where the denominator was 0, where the bottom was 0, that was our cosine. Where's the cosine 0? At pi halves, 3 pi halves, etc. Okay, so those are our basic facts about our tangent. You know those off the top of your head. No big deal. Now, what does the 2 do to a tangent? It does the same thing to a tangent as it would to a sine, or a cosine, or a secant, or a cosecant. It makes the graph occur twice as frequently. So it reduces the period, and it cuts it in half. So guess what you do to all of these x-coordinates? The same thing you did to a sine, or a cosine, or a secant, or a cosecant. You multiply all these x-coordinates by the reciprocal. So multiply all these by pi, by 1/2. And so now our new zeros for the tangent of 2x, because it's occurring twice as frequently, our zeros will still be at 0. Multiply by 1/2, and we get pi halves. And we get pi. And the vertical asymptotes multiply by 1/2, and I get pi fourths, and I get 3 pi fourths, etc. So we come here, we label our graph. I'll put a 0 right there, and then I'm going to label this pi halves. Got a 0 there, and there's pi. Got a 0 there. My vertical asymptotes are at pi fourths and 3 pi fourths. So there's a vertical asymptote. There's a vertical asymptote. And what do these graphs look like? Tangent graph loops up to the right, down to the left. Up to the right, down to the left. So we use our zeros, we use our vertical asymptotes to establish where the graph goes, and then we just remember that basic shape. We could go through and plot points to really get at that basic shape, but like I say, we're not emphasizing these quite as strongly, so this would be sufficient. All right, 2 more of these to see. What do you think a minus pi fourths does? The same thing it's always done. It shifts the graph to the right pi fourths. So before we do that, let's remind ourselves of just a regular cotangent graph. Where are the zeros? Where are the vertical asymptotes? Let's make that a colon. All right, the zeros for the cotangent graph were at pi halves, 3 pi halves. The vertical asymptotes were at 0, pi, 2 pi. How do you remember those things? Because cotangent is cosine over sine. The cosine is 0 at pi halves, 3 pi halves. And then the cotangent is undefined, where the bottom, where the sine is 0, which is a 0, pi, 2 pi. All right, just as in the past, minus pi fourths, what do we do to our x-coordinates? We're going to add on pi fourths. So now for the cotangent of x minus pi fourths, what do our zeros become? Add on pi fourths. What's pi halves plus pi fourths? 3 pi fourths. What's 3 halves plus a fourth? 7 pi fourths. All right, vertical asymptotes. 0 plus a fourth, nice and easy. Pi fourths, pi plus a fourth, 1 and a fourth, make it improper. 5 pi fourths, 2 plus a fourth, it's 2 and a fourth, make it improper. 9 pi fourths. So on our graph here, let's choose a scale of pi fourths. And once I choose that scale, I have to consistently use it. I can't vary my scale. So here's pi fourths. Here's 2 fourths, otherwise known as a half. Here's 3 fourths. 4 fourths, otherwise known as pi. 5 fourths. 6 fourths, which reduces to 3 halves. All right, let's plot our points on here. We've got zeros at 3 pi fourths. And 7 pi fourths, which would just be one more down, because that'd be 7. We got vertical asymptotes at pi fourths. And then our next one is at 5 pi fourths. And our next one isn't really going to show up. It would have been 9 pi fourths, which would have been down here somewhere. And then remember the basic shape of a cotangent graph. It goes down to the right and up to the left. So we can get these zeros, and we get these vertical asymptotes for a tangent or cotangent graph. You pretty much have the whole graph. So it's just a regular cotangent graph shifted to the right by pi fourths. All right, I know this video is a little longer, but it's only one. Here's our very last one. What if you put numbers in front of a tangent or a cotangent graph? Well, first of all, the 3 in front, that's the amplitude. But guys, that doesn't make a lot of sense for a tangent graph. The amplitude, it goes off to infinity. Same thing for a cotangent graph. So what does the 3 make a tangent do, or a cotangent? It still goes off to infinity. It just goes a little bit quicker. So that one doesn't affect the graph a whole lot. But the 2 would affect things. It's going to raise your graph 2 units upward. So raise your graph 2 units. All right, so let's think about our regular tangent graph. What are my zeros for a tangent graph? Remember, they're 0, pi, 2 pi. What are the vertical asymptotes? Pi halves, 3 pi halves. So come over here, I start to plot that. I got a 0 here. If I label this, sorry, pi halves, I should label my graph. Pi, 3 pi halves, 2 pi. I had zeros at 0, pi, and 2 pi. But wait a minute. The whole graph is shifted up to. All my y-coordinates would be, I'd add 2 onto those. So take those off of here and move all those up 2. So there's my new coordinate, there's my new coordinate, there's my new. So all those zeros, I'd add on 2. Vertical asymptotes, you can't really add on anything to a vertical asymptote. It's just a vertical line. So I've got this line, got this line, I'd have this line. And now instead of at 0, at 2, I have my tangent graph going up to the right, down to the left, up to the right, down to the left, up to the right, down to the left. And how do you take into consideration the amplitude of 3? Technically, it would go up a little bit steeper than a regular tangent graph. And I'll just show you this on the calculator as well, so you can see that. But it's really hard to show the amplitude because it goes off to infinity. So real quick, let's just peek at that with the calculator. So if I had tangent of x, and now if I put an amplitude 3 tangent of x, what's the difference in these two graphs? Well, here's your tangent of x graph. You can kind of see that tangent of 3. It looks very similar. Bring that over here so we can write on it. It looks very similar. it's just going up much quicker than our tangent graph was going up. So it still goes off to infinity. It doesn't really change the amplitude, but here was the tangent graph, and tangent of 3x, it's just going downward or upward quicker. All right, so that takes care of our tangents and cotangents. That takes care of all the graphing that we need to do. We can graph now sines, cosines, secants, cosecants, tangents, and cotangents. We are done.